After the discovery of over 1,000 planets orbiting other stars, what we now call extrasolar planets, a major focus for astronomers has changed from finding these planets to characterizing their surfaces and atmospheres in an effort to understand if Earth might have a twin, another planet with land and oceans capable of supporting life. If we think about the surface and atmosphere of our own planet Earth, biological life is responsible for most of what we see. Plants convert carbon dioxide and water into oxygen through photosynthesis, and this oxygen is released into the atmosphere where it supports life, like humans and animals. Mammals and other life forms convert oxygen into other signs of life, like methane. These gases in Earth's atmosphere are the signature of a thriving biosphere on Earth's surface. How do we detect these molecules in Earth's atmosphere? One technique used by astronomers is to study how these gases alter the sunlight that shines through the atmosphere. Every atomic element in molecular gas has a unique fingerprint that allows us to identify it within the sunlight spectrum. As light travels through a planet's atmosphere, its spectrum can become imprinted with biomarker gases. The Hubble Space Telescope uses this technique to observe distant stars for the presence of these biomarker gases. By studying these spectra, we can measure the types of gas around the stars and investigate if life could exist beyond our solar system. As astronomers look beyond our own solar system for signs of life elsewhere in the universe, they frequently look to red dwarf stars. Red dwarfs are the most numerous types of stars in our galaxy. The nearest rocky planets that might be capable of sustaining liquid water on their surfaces orbit red dwarfs. Given the great distance to even the nearest stars, we can't see life directly. So, we rely on the spectrum of their atmospheres to give us clues about the conditions on the surfaces of these worlds. But what will Earth-like planets around red dwarf stars look like? How will they be different from our home planet? Red dwarfs are smaller and cooler than our Sun. With the Hubble Space Telescope, astronomers at the University of Colorado Boulder are studying the high levels of magnetic activity that lead to intense X-ray and ultraviolet radiation delivered to the planets that orbit them. This magnetic activity also leads to massive stellar flares that send high-energy charged particle storms into the planetary atmospheres. The University of Colorado Boulder team is investigating how this intense ultraviolet radiation alters the chemical balance of an exoplanet's atmosphere. High-energy radiation can convert carbon dioxide and water into oxygen. In the atmosphere of a planet around a red dwarf, high concentrations of oxygen may be found in the absence of photosynthesis. That is, without being formed by life. So, on a planet orbiting a red dwarf, a biomarker gas might not be a marker of biology at all. Can life survive and evolve on planets subjected to the harsh conditions found around red dwarf stars? Can we identify the telltale signs of life on planets orbiting red dwarfs? In the next decade, NASA will study the atmospheres of dozens of planets around red dwarfs. In 2018, NASA will launch the James Webb Space Telescope, which will be the first instrument capable of observing potential biomarker gases around red dwarfs. The James Webb Space Telescope will look at the spectra of these systems to determine if biologically active gases are present in the planet's atmosphere. The research done by the MUSCLES team will allow us to diagnose the origin of this gas. Are these gases produced chemically in the planet's atmosphere? Or are they the result of biological life on the planet's surface? As astronomers build up the list of planets that have the right mix of ingredients for life, the Hubble Space Telescope continues to play a crucial role in understanding the observations of Earth-like planets for the James Webb Space Telescope and other future NASA missions. All of these pieces are necessary to unravel the answer to one of mankind's oldest questions. Has life developed elsewhere in the universe?